Good day, everyone. I'm Kolade Oluwafemi Ahmed. Welcome to my channel. Today's topic is elastic property of solid. Sit down and enjoy yourself. This class promised to be an interesting one as it used to be. Enjoying your class. Now we'll be looking at elastic material to start with. These are substances that can undergo temporary deformation when subjected to external forces and return to their original shape and size once the force are removed. That is, if you expand it, it will expand. When you release your hand from it, it will go back to the same shape. When you compress it to make it reduce, when you remove your hand, it will go back to the same shape. Now, examples of elastic material like rubber, spring, elastomers, that is e.g. silicone, natural fibers, Borgese cord, stretchable fabrics, that is some clothes can be stretched. They are all examples of elastic material. Now, let's go to characteristics of this elastic material. The very first one is deformability and recovery. That is, elastic material can be deformed. That is, you change it from the way it looks by compressing it or by making it longer than before. And after the force that used to deform it has been removed, it will return to the same way it is. Now, another characteristic is elastic limit. All elastic material, they have elastic limit. They have a point where they will not be able to return to the way they were. Hooke's law is one example of the characteristic of elastic material. That is, elastic material obey Hooke's law. That is, they can be what? That is, the force used to stretch an elastic material is proportional to the extension of that material produced. Also, stiffness and resilience. Also, they are the characteristics of what? Elastic material. That is, elastic material possess what we call stiffness, that is, which is also known as what? Rigidity, which means they are resistant to deformation. Before you can deform an elastic material, you have to put in an effort, a force that will be able to do that. Now we're talking about energy storage and dissipation. When you apply force on an elastic material, maybe you press it, it stores energy. When you release the force, it does what? The energy produced, does it make the elastic material to return back to its original shape? I hope you are learning something. Now, looking at the diagram beside us, you see a spring where it's being compressed, then when it's being what? Expand. Also, you see that rubber band telling us that there is an example of material that can be what? Expand. Let's move. Next, what we'll be talking about is what we call elasticity. Elasticity, what does that mean? Elasticity refers to the property of material that will allow it to deform under the influence of an external force and return, mark that, to its original shape and size when the force is removed. That is, the property of a rubber to what? To undergo deformation and return back to where it was before is what we call elasticity. Now, having learned that, we proceed to what we call Hooke's law. What is Hooke's law? Hooke's law states that the force required to stretch or compress an elastic material is directly proportional to the displacement, that is the increase in the length, provided the material remain within its elastic limit, that is, it does not expand beyond when it can return back. to its original shape. Looking at the mathematical expression there, Hooke's law, F is proportional to the change in length. When that proportionality is taken away, you have K multiplied by change in length. F is the force, K is the spring constant, that we have change in length. That is that concerning Hooke. Then the next thing we'll be looking at is what we call stretch and strain. Stretch can be defined as the force per unit area acting on a material. That is the symbol there, that we have force over area. Then we talk about the common type of stretch, the tensile stretch, that is when the material is being expanded in a elongation. Then compressive stress, it is when the material is being compressed. Then shear stress is talking about when two forces perpendicular to each other acted on the material. That is when we have shear stress, and they are opposite to each other. Then the strain indicates the relative amount of deformation or change in shape. When there is change in shape of the material under the applied stress, that be under the applied force, talking about the strain. And we can see the mathematical expression there, that is representing strain, change in length. Then L naught means the original length. It has no unit, unlike the strain, which is what, Newton per meter square. Then we have examples of strain, like tensile strain, compressive strain, and shear strain, which is almost the same thing as that of stress. Then with that, it to what we call Young modulus. Young modulus is a relationship between the stress and the strain. That is, Young modulus E means the ratio of stress to strain in the elastic region of the material stress strain curve. That is the relationship between stress and strain. That's what we call Young modulus. Looking at the expression there, that is E is equal to that of stress over strain. The unit is Pascal. As you can see, Young modulus is equal to force over area, which is the stress, change in length over original length, which is the strain. Now, with the little we'll be able to achieve now, I want you to take this self-exercise to know, maybe you'll be able to learn some. Discuss two relevance of elastic to solid material. Identify and describe two characteristics of elastic material. Deduce an expression for spring constant. In conclusion, understanding the elastic property of solid material is essential for designing and analyzing structure, predicting material behavior under load, and selecting appropriate material for specific application, such as in building. I'm talking about the building engineer, civil engineers. They have to put in place these characteristics of material to know the stress, the strain, in order to determine the material they're going to use for their building. Young modulus characteristics such as material stiffness, material dependence, elastic limit, material testing, engineering application are key parameters that characterize a material mechanical response to different type of deformation. This one will go a long way if it is put in place before we start doing our building, before we start constructing, before using any material for any construction at all. You have to put in place their characteristics, their properties. Thanks for watching.